I'm Tomohiro Oda from Software Research Associates. My today's talk is about formal method. Not really. It's a kind of a hosting a formal specification tools on top of Pharo Smalltalk. So I'd like to make some little self-introduction. I've been enjoying Smalltalk programming since '94. My first Smalltalk was Smalltalk V and Visual Smalltalk. I enjoyed some parts workbench out there, and then moved to VisualWorks and did some Squeak work, and then now I'm mainly using Pharo. And I've been developing some 3D graphics library on top of VisualWorks that provides some OpenGL interface. And my main job as a programmer is doing some, research prototyping, collaborating with some researchers at the university. So my company, Software Research Associates Inc., has a little confusing name. Sometimes people say, research associates, so it's non-profit research support group, but it's Inc. So we are business people. So we are corporation. So actually, we have been doing software development business since '67. It's a little before I was born, actually. Also, kind of one of the earliest adapter of Smalltalk in Japan. And we are very proud of, co-organizing Smalltalk Day Japan. We had that this year with Stefan Dukas having a keynote speech out there. So, and another co-organizer was Smalltalk Study Group, Tokyo. Actually, we have some Smalltalk group in Tokyo and having monthly meeting at Sorabito's office. So if, any of you have any business or something doing in Japan about Smalltalk related things, please remember we are out there. So, yep. Oh. Wake up, wake up. Okay, cool. So, and also I'm, as a programmer, I'm collaborating with some kinds of people. First of all, Smalltalk people, so it's you. And also I'm collaborating with some formal method community in Europe and Japan. Especially I'm working with VDM, Vienna Development Method. That is a very practical, lightweight, formal method that kind of take importance of executing specification. And also some other scientists like chemists, biologists, economists, I'm kind of doing prototype research prototyping for them. So let's go back to the main topic, that is the ViennaTalk. Is formal tools on top of Smalltalk. So I'm kind of trying to bring the spirit of Smalltalk programming, kind of exploratory, debugging, and dynamically changing many things while executing into a formal specification. So it has a collection of tools, and first of all, the most important part is execution engine. And we say that's not really execution, but that's simulating the execution of the system that implements the specification. Okay, so we have some interpreter that is written in Java, and that is kind of de facto standard among VDM researchers. That is called VDM-J. It can be called from Smalltalk. And also we have cloud interpreter that is provided by ViennaTalk, that we have web API at public place, and we can send specification and state definition and expression to evaluate. Then we can get return value and resulting state definition. And also ViennaTalk provides a Smalltalk code generator that Smalltalk VDM specification can be automatically turned into a Smalltalk library. And as a tool, there is a web ID, very simple one, to start with very small piece of specification to scratch idea, and then bringing it to a VDM browser that is a Smalltalk-like browser to explore the solution that has a printing printer, syntax highlighter, workspace kind of thing, and inspector, and do it, print it, classical Smalltalk tools. And also, library walkthrough is a UI prototyping tool that the formal specification engineer and UI designer can come together to build one UI prototype to grow their common understanding about the system. And also, every walkthrough is a kind of a little tool to publish a specification as web API. I'll show you a demo about that. And my latest work is ViennaTalk. That is to produce a dynamic document that can be executable and testable. Okay. So this is what I want to say today. So Smalltalk is not alone. So Smalltalk sometimes take some polyglot approach, but besides that, some hosting different language on top of Smalltalk is fun. It's very pleasure to do that, to see that Smalltalk way of doing influences the taste of the guest language. And this is the VDM-SL, that is a specification language that ViennaTalk execute. Here's some, it's module based, so module definition and give some, a interface definition, define types with type invariant. That is constraint on the values of types. Then can define some constants and state definition with statically typed variables with again invariant constraint, and can give some initial condition, and also can define some operations. It's like procedure, has some signature and the body of definition, and optionally some precondition and postcondition. It's something like that, quite simple. And this is, simple comparison between Smalltalk and VDM. It's very different. So, of course, dynamically typed and statically typed, but VDM-SL has no notion of classes or objects. So it's just consists of pure functions and stateful procedures. And also Smalltalk's programming language and the VDM specification language. And Smalltalk's strength is that interacting with humans, but VDM does not care about interaction or people, so it values computation. So it's very different. It's kind of sad news, but it's very good news to make a code generator, because there are no subtle difference. Because if it's not VDM but a Java, little difference between the object model, access control, those kind of thing would matter. But in this case, no confliction. So it's kind of easy to implement a code generator. And again, it's rather, a complement each other. That Smalltalk has a rich class library, but the VDM-SL has no library mechanism as a specification language feature. And also, Smalltalk has strong context verification mechanism that we can see the execution context. But in VDM, we don't have that. But we can statically analyze what is going on using a precondition and postcondition. And also same to reflection, that we can change the method and those kind of things during execution. But in VDM, we rather assert what properties should be satisfied at any moment of execution. So that's quite different, but kind of, I think, a good complement. And, message passing, pattern matching, those kind of things are very different. And Smalltalk, the great part is we can start execution before finish coding. It's very fun. And in case of VDM, we can say that we can simulate execution before start coding, because it's not executing the specification, but it's simulating execution of the code that implements the specification. Okay, then why I want to bring Smalltalk way of doing to VDM is, to define a formal specification, we can't make perfect specification at the first time. It's just impossible. We have to learn from the product in action to make better specification. So I think it's very exploratory process, and I think Smalltalk way of doing is very good influence to that. So I'll go to demo. So first I'll show you a VDM pad. That is a simple web ID here. So this is looking like something that I showed you before. Yes, of course, I just screen snapshot it. So this part, this is too big. Okay, this part is, code pane, not code pane, specification pane, that you write specification here. And here is a kind of, variables and its values that I can edit the value. For example, I can turn the count to 0, and then I can write the expression to evaluate here, reset, no, not reset, get. Then what will happen is, no definition of get. Sorry, just a moment. Okay. Okay, I just typed in, semicolon. Okay. Then I can evaluate it. Oops. Oh, really? No? Oh, no, not get, count. Okay, go. Okay, got it. So the answer is 0, of course. So as you see, I edited the code and edited the value and gives the expression, evaluate, then got it. Could be in any order. So I can say evaluate again. Oops. Then I can say here increment, go, then got 1, 2, and I can change the value here and then evaluate, then go to 1. So it's just like this. And as you see, I could change specification at any time, but that sometimes make trouble that, once I and my client agree that, this behavior is okay, then I want to keep it. So, for example, now it count is 1 and evaluate it, then count is 2 and return value is 2. I want to keep this thing. Oops, sorry, I forgot to. Okay, turn the unit testing. So this is make it a test case button that creates a test case for this specification without writing the test code. The previous execution that count equal 1 and increment then get a 2 becomes a test case. And if I say again, evaluate, okay, it's now okay, but now I change some behavior here. It's not working. Uh-oh. Ah. Not working. Sorry. Suppose we, unit test is running on background and say the assertion that I defined before is, oh, here. Okay. So I change the definition here, 1, and do some evaluate here. Then I changed again, so the unit test failed. So I can find that the promise with my client made before is broken. So I have to recover it soon. Okay, this is VDM part, and next one is VDM browser, something like this. So this just says what it does. Just here is a list of modules and variables here. Oops. Oh, unsave that here. Here is a workspace here. And I can do, evaluate or those kind of thing here. And here I can use this as a work inspector so that I can also evaluate something here. Yeah, something like this. Or yeah, something like this. So, and this also has a unit test feature that, this counter is too simple. So I'll bring up a better example. This is a virtual machine specification that I'm now developing. That's a virtual machine between VDM and that runs VDM specification. It's in middle of development, so it doesn't run really. And if I change something here and accept it, oops. If I make any, oops. Sorry, again. It will automatically unit test will run and shows which test results. Not working. Yeah, and the failed test will be informed in yellow, and if got some error test, then get a red notification here. And also in the similar interface, we can publish the specification as web API. Now it's serving on at the local host 87. So with my browser here, I can just kick the specification as an API and get a return value 1 or those kind of things. Okay. Okay, we come to every walkthrough. Oh, no. I skipped the library walkthrough. That is here. Okay, this is a UI prototyping to very simple one. I have a specification here. Sorry, it's too small. Ah. Okay, and here's some widget, UI widget, and I can write some glue code of this increment buttons clicked, then evaluate this VDM expression, and return value will be sent to count display widget. It's here. So I click increment, then specification runs and gets a result 1, 2, 3, and reset, or something like this. So using this, the UI designer and specification designer come to one place and, collaborate each other. Oops. And the last one is ViennaTalk. That is a documentation tool. Here. Okay, this is kind of HTML documentation that explains the formal specification. This is everyday's counter example, and it explains in plain English. And it has some run button here. Oops, sorry. I'll just reload this. Okay, so this run button, I click it, then specification runs and shows a result that before execution, the value of the variable count was 0, then evaluated inc, then got the unit value, and after the evaluation, the variable count is now set to 1. And I can just repeat doing this again, getting incrementing number. And same to these buttons, run buttons. I can do that. And here, I get some strange message here. Invalid something, 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 something. Okay, what it means is I placed some assertion code in the HTML that, in a code element, if it has attribute Vienna equal assert, and these definition of state definition before execution, kind of setup routine. And in this counter module, evaluate this expression. And so it evaluate reset operation, and then gets the value of count. And the second, so return value is the value of count. And this document expects it should be 1, but the system says it evaluated to 0. So let's see the definition here. So it's defined, just assign 0 to count. So at first, it used to be set 1 to the variable count, but specification changed. So have to update this document. But just document, I just forgot to update this part. So the system ran the assertion check at the load time of when the browser load this document. It evaluated it and compared and found something is wrong here. So if I just correct it, so now I edited the HTML source here and I reload it. So I changed, here, counter to 0. So I changed the content from 1 to 0 here. So the system does not complain because assertion succeeded. So using this, we can check the consistency between the explanation and formal specification. So, oops. No, not this one. Not this one. Here. Okay. Oops. Okay. So that's all of, okay, the demo is all. So far, I gave this to my collaborator at academic and also industry, and they say VDM pad was accepted very okay at the classroom setting. For example, some introductory class to formal method or VDM for new engineers. So tutors and students both said VDM pad was easier than other tools. But also it has some limitation to auto-generate part that sometimes it's just a power compiler just complains this method is crazy. It requires too long jump. It's beyond the limit range. And also sometimes user seems to get confused by saving image and saving files that, it's always problematic. And about this project, I have still pile of to-dos. The specification document needs some Git support and migrate to spec2, type checker, completion, and those kind of things. Okay. And this is a list of packages in ViennaTalk. And for each package, we have a few or several classes. Yeah. And so I used those piece of softwares available in public. So I thank contributors and everyone in Smalltalk community about enabling this project. So thank you very much.